Okay, let's talk next about mutual. We're going to introduce the concept of mutual independence now. Mutual independence is what applies to more or less arbitrary combinations of events. So a combination of events is any event that can be formed by the basic set theoretic operations. What are those? So we can use union, intersection, complementation, and we can do it any number of times. So for example, say that we have events A, B, C, and D. What are some combinations? A is a combination. A complement is a combination. So it's any event that it can be formed using the operation of union, intersection, complementation on those sets. So A in itself is a combination. A complement, A intersect B. Of course, you can get more involved. A union B, union C, intersect D complement, and so on. And then you could, add on as you wish. Okay. For three events, how do we extend the definition? A, B, and C are mutually independent. We usually leave this term mutually out, but they're mutually independent if every combination of some of them is independent of every combination of the rest of them. Now, this is not the most precise definition, but this is to give you some intuition for what we're talking about. What we've defined above is what would be called pairwise independence, or just independence for two events. So that's our working definition. Now, what we generally always want to do is when we're going from, let's say, when we're talking about a definition of something that applies to, let's say, one or two, and we start in the simple case where we only deal with one event or two events or one probability or one random variable later on, and so on and so forth. We then want to extend that to arbitrarily many. Okay. When we extend that definition, it's really only it's only a proper extension if the general definition in the special case of one or two events reduces down and is identical to our original definition. What we often like to do is we often like to bootstrap our initial definition. What do I mean by that? What I mean is we like to kind of define a more general notion in a way that really just leverages the first definition. In this case, we're doing that because we're saying, take a combination. A combination is an event. Okay. And then take, so a combination involving certain sets, A1, A2, A3. Take the rest of the sets, take a combination of what's left over. Now you're still left, you have just two events. Okay. So we know what independence means for those two events. Mutual independence says, okay, we're going to talk only about pairs of events, but it's going to apply to every possible conceivable pair of such events. Okay. So we're going to make this more precise momentarily. But if this is true, then what we can say is probability of the intersection is the product of the probabilities. And this is where I'm using this notation of a superscript bullet. What that means is I'm allowing A dot to be either A or A complements, B dot to be either B or B complement. So what's saying is it doesn't matter which you plug in. Whichever you plug in, there's 8 different combinations. It's the probability of the intersection of those sets is the product of the probabilities. Okay. So now, in general, if we have n events, A1, A2 up through AN, they're independent if or we can think of them as mutually independent. If same concept holds, and every combination is independent of every other combination of the rest. And what that ultimately boils down to is that the probability of any intersection of the event or its complement is the product of the probabilities for all choices here. AJ dot is either AJ or AJ complement. Or equivalently, so, or takes some work to prove that these are equivalent, but, or we can just say probability of the intersection of any subset of them is the product of those probabilities. And this is for all subsets of the indexes. Okay. So this is our working definition of mutual independence. We'll see how it comes into play throughout this section. We're going to work on several examples, and we're going to start that next.